Hello everyone. So this is the recording of the remaining problem of our final exam preparation sheet. So I'll skip all the points like this. We already did that in class. So basically the vectors, you have to know all the calculation about vectors. I think you should be really aware of this right now. And all the vector value function and all the different kind of integral. And again, this is double integral. Oh no, this is fine. This is fine. And I think this should be fine. This should be fine. This should be fine. Yeah, here. This should be double integral. This should be double integral. But you know what I mean. And these are all double integral. Okay, so let's do the remaining problems. So let E be a solid region bounded by Z equals x squared plus y squared, blah, 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 blah. So part A is what is the name of this surface? So I don't think you have to know the name. Like you don't have to memorize or match it one by one, but you have to know what somehow it looks like. So this is actually a paraboloid. So this is paraboloid. But the idea is that you have to know how to draw something like that. For example, can you draw the level surface of this guy? So review, like level surface, level curve, sorry. So it's basically just fxy equals k. So if xxy equals k, then what does it look like? So for x, where k equals k. So in this case, there will be a level curve or like a circle. Okay? And when z is growing up, so it's like a paraboloid, it's like a parabola, so it's called paraboloid. I think the more important part is you need to know how to draw the level curve. And that's it. And that will be fine. And next, we find the gradient of this guy. So gradient f is just derivative. So it's just 2x, 2y, and -1. Basic calculation. Now we use the linear approximation at 1, 1 to estimate this value when 1.1 and 0.9. So again, Lxy at 1, 1 will just be f11 plus fx 1, 1, x minus 1 plus fy 1, 1, y minus 1. And this is my fx, this is my fy, so we just plug in the value. We just plug in the value, so this will just be f11 will just be 1 plus 1, 1 plus 1. This is my f, so yeah, this is a slightly notation weirdly, so my fxy is here. If two variable, this x squared plus y squared, this is equals z. Okay, don't confuse with this guy. Don't confuse with this guy. Okay, so that will be easier. So this will just be 1, 1 will be 1 plus 1, so it's 2. And this is 2x at 1, 1, so 2x minus 1. 2y again is 2, y minus 1. So f 1.1, 0.9, which is really close to this guy. L 1.1, 0.9. So it'll be 2 plus 2, 1.1 minus 1 plus 2, 0.9 minus 1. So it'll be 2 plus 0.2 and plus negative 0.2. So it is still 2. It is an approximate value. So we use this method, we get 2. Even though its actual value is not 2, but we know it's close enough. Okay. So this is gradient calculation, linear approximation, and 1.6, the quadratic surfaces. Again, you don't have to memorize what function is what. You don't have to memorize, okay, like, okay, this is like hyperbolic of 1 sheet, 2 sheet, doesn't matter right now, but you have to know how to find the level curve. Okay, now we have to find the tangent plane. So again, the function looks like this, z equals x squared plus y squared, or we can write it as this guy, fxyz. This is the implicit one, will be x squared plus y squared minus z. So at least we know how 2 ways to do this. So way 1, if you remember this, way 1, the tangent plane for z equals fxy. The tangent plane is this guy, z equals fab plus fxab x minus a plus fyab y minus b. And I think you already know that this is basically the linear approximation. So we already did that. We already did that above. So this will just be z equals 2 plus 2x minus 1 plus 2y minus 1. So we simplify this. This will be 2x plus 2y minus z. I move every z out this way, and -2, -2, and -4. We -4 and +2, so it just -2 equals 0. This is one way to do that. And the second way, we use the implicit function. Oh, implicit function. So for f(x,y,z) equals 0, the tangent plane will look like this. The normal vector, normal is gradient of f. So it will be fx, fy, fz. And for the plane equation, we only have to know normal and a point passing that tangent plane, and we're done. So that's what we need. So we already have this. This is 2 to -1. So the tangent plane is just with this vector and passing through 1, 1, 2. So tangent plane will look like this. Will be 2x minus 1 plus 2, y minus 1, and plus -1, z minus 2 equals 0. And we simplify that again, 2x. Again, we have 2x, 2y, and minus z, -2 plus 2. So it's still the same thing. Yay. Same thing. And now after chapter 16, we have a third way to do that. We have a third way to do that. So way 3, we can parameterize this surface. So in this case, x and y doesn't matter. We only care about z. So x and y can be our two variables. So r, x, y will just be x, y, fxy. So in this case, will be x, y, and z equals x squared plus y squared. And the normal vector will be rx cross ry. In this case, rx is 1, 0, fx. ry is 0, 1, fy. I'll leave the calculation to you. Trust me, they'll give the same answer. They'll give the same answer. So in this case, at 1, 1 will be 1, 0, 2. This is 0, 1, 2. So rx cross ry will be this, I, j, k, 1, 0, 2, 0, 1, 2. So it would be, for the I part, it is 0 minus 2. So it would be -2. And for j part, it is 2 minus 0, but negative sign, so -2. And for the k part, it's 1 minus 0, so it's 1. So it's 1. So again, we can see that these are basically they're parallel. They're all parallel, so they'll give the same thing. I'll leave the calculation to you, but basically you'll go back to this one. I think this is pretty straightforward. So now we have 3 ways to find the tangent plane. We have 3 ways to find tangent. And next, we want to do directional derivative. So again, if a function is differentiable, the directional derivative du will be gradient of f dot u. But be careful, u has to be a unit vector. But now the direction of the vector u340 is not a unit vector. So how do we make the vector unit vector? We'll just divide by its magnitude. So u will just be v divided by its length. So it'll be 3, 4, 0. This is 3 squared plus 4 squared. Take a square root, and we all know that this is 5. So this is 3 over 5, 4 over 5, 0. And we already have gradient of f. So gradient of f. Sorry, I'm a little bit sloppy, but you know what am I doing. So this guy will be 2x, 2y, 1, and dot this guy, 3 over 4, 5, 4 over 5, 0. But we care about at 1, 1, 2, so we'll just plug in x equals 1, y equals 1. So in this case, du f11 will just be 2, 2, 1, dot this guy. So it will be, oh, 2, 2, -1, sorry, -1. So my f is x squared plus y squared minus z, right? So -1, -1. But it doesn't matter. But it doesn't matter since -1 times 0 is still 0. But I just want everything accurate. So this will be 6 over 5 plus 8 over 5. So 14 over 5. We're done. We're done. Okay. The next thing we want to care about is this guy. Find the maximum rate of change at 0.112. So remember, we have this for gradient, for directional. I just spoiled the answer. For directional derivative, the absolute of this guy will always smaller than the gradient of f. In this case, we can write this negative gradient of f smaller than du f smaller than gradient of f. So the maximum value will just be the gradient. The maximum value will just be the gradient. So maximum is gradient, absolute value will just be gradient f. So this will be gradient, remember, is 2 to -1. In this case, just 4 plus 4 plus 1, so 3. So next, we want to find a direction. Again, remember that du f is gradient f dot u, right? If u is a direction vector. And remember the definition of the inner product, dot product is gradient f times u cosine theta. So this is 1 by our construction. So if we want that to become the gradient f, cosine theta has to be 1. So it has to be the direction of the gradient, and that's it. So it has to be the direction of the gradient. So if, in this case, maximum happens when u is parallel to gradient f. But remember, u has to be a unit vector. So we cannot just use 2 to -1. So u will have to be the gradient f divided by gradient f. In this case, it will be 2 to -1 divided by 2 to -1 magnitude. So we already did that. The denominator is 3, so this will be 2 over 3, 2 over 3, -1 over 3. And that's it. And that's it. That's it. Maybe I shouldn't write parallels. In parallel means that it can be another direction. It's the same direction. It's the same direction. Okay? So I think that's one thing we didn't cover that much, but remember this, the maximum rate of change or directional derivative along any direction is the gradient. And when maximum happens, it is the direction of the gradient. Finally, I think we still have one question. Set an integral to find the volume of solid E. So E is bounded by, I don't remember. Oh, x squared plus y squared equals z and 4. So we can somehow draw it like that. So this is, this is like this. So this is this. Remember, level curves are all circle. So this is z equals 4. This is z equals 4, and this is z equals x squared plus y squared. I want to find the volume of this guy. So remember, volume is just triple integral 1, right? So volume is just triple integral over E1 dv. So again, we cannot just write this. We want to do something that we can do that. So we need to use Fubini. So the idea is that Fubini is that we have to project that into a different plane and to see how to integrate that. So I think the easiest one is we just project onto xy plane, then we do dz first, then dx dy or something. So in this case, we write this as rxy, if you remember this. We want to find this. So in order to find this z, we need to find what is this. What is this? So z equals x squared plus y squared equals 4. So this rxy is x squared plus y squared equals 4. So now this will be double integral rxy, and this is dz. We need to find dz. So now it's 1 dz dA. Okay? So we need to find what is inside. So now if we want to integrate with z, we need to see where z go from where to where. So in this case, z go from here and up to 4, right? Z go from x squared plus y squared and up to 4. So this is x squared plus y squared and up to 4. Okay? The working method. When you do the integral, the inner one will be function to function, and we can see z go from where to where. And now for the double integral part, this is x squared plus y squared equals 4. It looks circular to me. So what about we just use polar coordinate, or in this case, the whole thing is just cylindrical coordinate. So again, in this case, r is from 0 to 2, and the whole circle, so theta is 0 to 2 pi. So it's a rectangle, but usually I just write r first, so it's 2 x squared plus y squared for dz. But be careful, for cylindrical coordinate, we need to add an r. So it will be r dz, dr, d theta. And that's it. And I think this is even doable, but I'll just skip that here since the question only X set up. So the calculation is not impossible, doable, but yeah, I don't want to say, I don't want to waste time with this. So that's it. That's it. So this is question 1. We cover basic vector calculation, gradient, even the quadratic surface, linear approximation, tangent plane, and directional derivative, maximum directional derivative, and how to set up the integral using cylindrical coordinate and triple integral. And that's it. That's it. That's question 1. That's question 1. And I think we did question 2 in class, so this is fine. So again, please review this. Please review this. Please review this. Please review this. This is important. We cover basically everything. Cover everything in chapter 16. So please review this. Please review this. Please review this. Doable. Everything is doable. Everything is doable. And now we are moving to question 3. Question 3. So now, again, these are all the things we already reviewed that in class, so I'll skip that. So basically, again, I label in red. So if you want to find the equation of straight lines, all you need to do is to find direction vector and the point on the line. And for planes, it's similar. All you need to do is to find a normal vector and the point on the plane. And all the application, I think you're probably really familiar with this. So velocity, speed, acceleration, and all the calculation. Remember, you have to plus C. And the limit, if the question asks you to do 2 paths and if the number is not the same, then the limit does not exist. And partial derivative is just, by this point, we should be really, really familiar with partial derivative. And chain rule, we did that in class. We have to draw the dependence chart. And finally, we have some derivative tests. So at this point, I'll say this is more important to classify that. To classify those things as more important. The calculation, you just take time. Maybe you don't have to do the calculation anyway, but you have to know how to classify. If the question gives you fxx, fyy, fxy, then you have to use that to deduce that, okay, this is local maximum, local minimum, or inconclusive. Or set point. Yeah, that's it. Same for the Lagrange multiplier. Maybe they'll give you lambda, then you have to compare what is the value and to find what is the maximum, what is the minimum. That's it. That's it. But I think I will still put some problem that we need to do the calculation. But don't worry, I'll do the calculation for you. So question 3, a drone set at P100 at velocity 0 to 1. Acceleration gives you the vector value function. I want to find the velocity, and I want to find the velocity vector and position vector. So basically VT, ooh, different color. So VT is just this guy taking integral. And when you take the integral of the vector value function, we're just doing 1 by 1. So 6t dt, 0 dt, negative 2 dt. So in this case, this will be 3t squared. Remember, we have to plus c. So c1, and this is 0, but it's just a number, so it's just c2. And this is negative 2t and plus c3. But we know that by the definition, by the condition, v0 is 0 to 1. So we can plug that in. So v0, it is c1, c2, c3. So equals 0 to 1. So we have our c. C is just 0 to 1. So c1 equals 3, c2 equals 2, c1 equals 0, c2 equals 2, c3 equals 1. So finally, we have a vt, will just be this, 3t squared plus 0. I'll just leave that. And c2, 2, and negative 2t plus 1. And we do the exact same thing. So do the integral again. So RT, sorry for the vector sign, but I think you know what I'm doing. So RT will be this guy, 3t, and and this guy dt, and this guy dt. So let me save the calculation to you. So this is just t to the power 3, t squared, and negative t squared plus t. Again, we have to plus a vector c. Okay? We need to plus a vector c. We need to plus a vector c. But now we also have r0 is 1. R0 is 1, 0, 0. So we plug that in. We plug that in. So R0 is 0, 0, 0 equals 1, 0, 0. So finally, we have R is this guy. We just have to plus 1 at the first component. I don't have space, but I will keep it here. Pew, pew, pew. So this is RT, will just be t to the power 3 plus 1, t squared, and negative t squared plus d. And that's it. And that's it. So basically just do just do integral twice and use the initial condition, then we're done. Then we're done. Then we're done. Okay, so what about the next question? So the drone flies from P to Q at t equals 1. So the drone legs are pointing to the direction at the velocity at t equals 1. Find the parametric equation for this tangent line. So basically, direction points at direction. So this means that this is my direction vector. This is my direction vector. This is my direction vector. So if I have a direction vector, I only have to find a point on the line. So at t equals 1, it reaches Q. So passing R1. And that's it. So that's why I say, if you want to find an equation of the straight line, you only have to find direction vector and the point passing. So now we just plug it in. So Q is R1. So R, we already have it. So it'll be 2, 1, and 0. This is Q. This is Q. This is Q. Let me check a little. I think I did some calculation wrong. I think I do some calculation wrong. Since, oh, yeah. This is 2. So this is 2t. This is 2t. So this is 2t. Okay, so Q is 220. Q is 220, and the direction vector is v1. So v1, we're just plugging v. V equals that. It's 3, 2, negative 1. That's it. So we pass through this one point, and we have direction vector. So straight line, parametric line would just be x equals 2 plus 3t, y equals 2 plus 2t, and z equals 0 minus t when t is all real number. We're done. We're done. That's it. We're done. Okay. So now after a straight line, now we have to find equation of plane. So find the equation of plane that pass through Q again and perpendicular to the strong acceleration A1. So again, this is a plane. Oh, this is a plane. This is a plane. This is a plane. Q is here. Q is on the plane. Q is on the plane and is perpendicular to the acceleration. So this is A1. Perpendicular. So this is my normal vector. So again, passing Q with normal vector. A1. So again, A1 equals what? We have the equation. So it'll be 6, 0, negative 2. And Q we already have it, so it's 2, 2, 0. So passing 2, 2, 0 with normal vector 6, 0, 2. So plan is just 6x minus 2 plus 0, y minus 2, and plus negative 2, z minus 0 equals 0. And we can simplify this 6x minus 2z. So 6x minus 2z and minus 12 and minus, yeah, just minus, wait, minus 12, right? So minus 12 equals 0. So finally we have 6x minus z minus 6 equals 0. What up? What up? What up? So again, you have to know how to find the equation on plane, equation on line. But basically, remember the fundamental idea. What you need to find is just a normal vector and the direction vector and the point passing those. And that's it. And that's it. So no matter how the question asks you in a different way, for example, we face question like, oh, find a plane equation containing two intersecting lines, find this containing two parallel lines, and whatever. You just try to find what is their normal vector. For this case, it's just cross product. So just V1 cross V2. Sorry, my direction. So this should be V1, V2, something like this. And for this one, say this is V1, this is also V1. We just choose 2 points on the line and we have V2. And we do V1 cross V2 again. Similar thing like that. So the fundamental idea, I don't want you to memorize in what scenario you have to do like cross product or whatever, but the idea is just a way to find a normal vector. That's it. Okay, let's move on. Let's move on. So now the drone is flying, and now we have a turbulence modified fxy. So we're on the x if the limit exists. So again, in this case, usually we can guess the limit not exists. We try to make it easier. So what about we just two paths? So path 1, what about x equals 0? So in this case, limit xy go to 0, 0 will just become x squared times y squared, so 0. So it's 0 plus y to the power 4. So in this case, everything is 0, so the whole thing is 0. Okay, but what about we use a different path? What about I use path 2, y equals x? This is our famous trick. So in this case, the limit 0, 0 will go to x squared times y squared is now also x squared. So now it's x to the power 4 plus x to the power 4. So now it's 2x to the power 4, 1x to the power 4, 2x to the power 4. So it's 1/2. It is not 0. So they are not equal. So limit DNE. That's it. That's it. That's it. So if you find two paths and they give you a different answer, the limit does not exist. Okay. So finally, we already done this dependent chart in class. So I'll leave the calculation to you, but basically B is this one. So this guy is 2P. If you want to do this, this is 2P. In PX, we don't have PX information. We don't have XT information, so leave it that way. So this is also 2P, and this is 3, and this is 3. And that's it. The other thing can be that way. We only know partial B, partial P, and partial P, partial H. So that will be the final answer. That will be the final answer. Finally, I want to classify all the critical point of this function. It looks terrible, but we'll try. We'll try. So again, if you want to classify all the critical point, you need to find what is critical point. So critical point happen when f is not differentiable or greater than or equal to 0. But you can see this guy. This guy looks pretty differentiable to me. So we just only have to find greater than or equal to 0. So in this case, gradient of f equals 3x squared minus 3. And fy is 3y squared minus 3. Oh, this is a good one. So we want to satisfy this guy equals 0. This has to be 0, and this has to be 0. So x squared has to be 1. Y squared also has to be 1. But in this case, x can be -1 or +1. Y can also be -1, +1. Be careful. This is what happened in your midterm too. We give the similar question. I don't remember the actual question. But basically, if you have these two cases, you have to include all cases. So when x equals -1, y can be all the two cases. When x equals to -1, y can also be two cases. So all critical points, therefore, are -1, -1, -1, 1, 1, -1, and 1, 1. So now we need to classify all of them. So we need to find the Hessian matrix. So basically, we already have fx. So f double x is this guy. We do that again. So it's 6x, 6x, and fy, fyy, is do again fxy, and fxy is this guy by 0. So dfab, the hashing will be the determinant of this guy, ffx, fxy, fxy, fyy. So this is 6x006y. So this will be 36xy. So we need to classify this. So 4 points to classify. So point 1. So I just have 1. Maybe I just have a bullet point at 1, 1. So we have D11 is 66, is bigger than 0, so doable. So when this is bigger than 0, so we're doable. So we need to check also fxx equals 6 is bigger than 0. So bigger than 0, so it's the local minimum. We do the exact same thing. So what about -1, -1? So in this case, D1, -1 is 36 times 1 times -1. So it's -36 smaller than 0. When you see something is already smaller, the hashing is smaller than 0, we can happily say it's a saddle point. It's a saddle point. You do the same thing. So -1, 1, again, D -1, 1 is -36, smaller than 0. So this is also a saddle point. Finally, we have -1, -1. So D -1, -1 is again 36, bigger than 0. And we also have fxx is 6x is -6, smaller than 0. So now we have bigger than 0, smaller than 0. So it's a local maximum. Or local maximum. That's it. That's it. I think this is basically really similar to what we have in midterm 2. I don't remember the actual number, even though I make that question, but I don't remember. But you know what I'm doing. Well, that's it. The calculation, probably you can drop it, but the calculation for this one is easy, but you have to know how to classify it. If you're given this information, can you classify this? And that's it. You need to know how to classify it. Okay. So now let's do the Lagrange multiplier. So if the drone flies through a safety rail, like you have to fly through a curve and doing some signals from bio. I just make some problem up, but you know what I mean. So basically, I want to find the 3x plus 4y, the maximum of 3x plus 4y on the curve x squared plus y squared equals 4. So when we set up the Lagrange multiplier, we have this gradient s. This is my function. Will become lambda g gradient g. In this case, gxy is x squared plus y squared minus 4 equals 0. And we also have satisfied gxy equals 0. So in this case, gradient of s is 3, 4. And lambda g will be lambda is 2x, 2y, this. And gxy equals 0 is just x squared plus y squared equals 4. So in the first one, we'll have this 3 equals 2 lambda x, and 4 equals 2 lambda y. Okay? So in this case, if we already have this, then we can rewrite x into 3 over 2 lambda, and y equals 2 over lambda. So we have x, y all in terms of lambda. What about we just plug in this one and solve the lambda? So everything will be a function of one variable. So we can solve what is lambda. Yay! So in this case, x squared plus y squared equals 4 will become this guy squared and plus this guy squared equals 4, which is squared up 9 over 4 lambda squared plus 4 over lambda squared equals 4. So this will be, I times lambda on both sides. So 9 over 4 plus 4 equals 4 lambda squared. So divided by 4, so 9 over 16 plus 1 equals lambda squared. So finally, we will have 25 over 16 is lambda squared. So lambda can be two cases. Will be positive 5 over 4 or negative 5 over 4. That's it. So if we have it, then we have x and y. So we have case 1 and case 2. So now remember, all local maximum will happen by the Lagrange multiplier. There's no exception. And again, since this unit circle is a closed and bounded curve, so basically the maximum or minimum we have is the actual absolute maximum, absolute minimum by the extreme value here. But in this case, we don't have to write that much. We just have to write maximum and minimum. So when lambda equals 5/4, we plug it back to x and y. So xy equal 2/3 lambda. Forgive me, I think the calculation. So 6/5. And 2/lambda will be 2/5. Sorry, 8/5. In this case, we plug back to x. So x will be 3x plus 4y. So will be 18 plus 32 and divided by 5, so it's 8. So again, case 2, where lambda equals -4/5. So basically everything should be negative. So xy will be -6/5, -8/5. So s again, 3x plus 4y will be -8. So we just compare which one is bigger, which one is smaller, and that's it. And that's it. And that's it. Wait. Yeah, I think I'm correct. Okay. We just compare which one is bigger, which one is smaller, and then we're done. So 8 is absolutely bigger, so this is the maximum. And this is the minimum. We're done. We're done. We're done. So that's Lagrange multiply. The basic difficulty will be in the calculation, but I don't think we won't bother that in your final, since that is, yeah, not important at this point. But you have to know the meaning. You have to know, at least know how to set up. Maybe the question will ask you how to set up. You need to know how to set up. Okay. So this is for basically chapter 14. So now we're moving to chapter 15, like multiple integral. And again, as I said in class, at this point in chapter 16, there's 4 of multiple integral. So now we should be really familiar with this kind of thing. But like double integral for this one, the inside one is function, outside one is number. So there's a function 2 variable, function 1 variable, constant. So I always want to say from harder to easier. So inside to outside is harder to easier. Okay? So that's this is my philosophy on how to set up the multiple integral. You can use your own way, but I recommend using this. So I think this is relatively okay. Finally, again, you have to memorize all of this change of variable. Please, you have to memorize all of this change of variable. Since even though we don't put in, even if we don't put any question on chapter 15, in chapter 16, you still have to use those kind of things. So please memorize all of them. So polar and cylindrical have an R, and for spherical, it's pretty ugly, but you have to know this. Okay? This guy. If you remember, I asked you guys multiple times in class, and I barely got a correct answer. So please memorize spherical coordinate. Important, important, important. And the volume and average value, these are all the usual stuff. Okay. Did I provide? Oh no. Okay, so let's do problem. So if a reservoir of it look like this, bounded by cylinder x squared plus y squared equals 4, the plane z equals 0, and the cone like this, and I want to find the integral of this guy. I only want to find this of like double integral by this guy. So now, this is nothing to do with reservoir. Okay, this is nothing to do with reservoir. So the D is a triangle bounded by y equals x, y equals x, y equals 2, and x equals 0. So this is my triangle. So we can solve it. This is 2, 2, and this is 0, 2, and this is 0, 0. So now I want to set up this D, E y squared dA. So in this case, if we want to, even though the question only asks it to set up, but if we want to calculate that, we cannot integrate with y first, since we don't know how to do e to the ey squared, right? So in this case, the natural choice will be integrate with x first. So again, this is a working method. So if I integrate with x first, I need to see where x go from where to where. So x go from here to here. So x go from 0, but this is y equals x, so x equals y. So this will be 0 to y, ey squared dx, and y now is just a number. So this is the setup, but the actual calculation is easy since this will just be 0, 2, like since this will be y ey squared dy, and we can easily do u sub here. So u equals y squared and blah, blah, blah. Then you can calculate an integral. I'll leave that to you. It's not too bad. It's not too bad. That's it. So what about the second question? Set up the triple integral that represent the volume of E. So again, now we have to use this thing. So it's bounded by the cylinder and some plane and a cone. So this cone is like a reverse cone. So it looks like this. You don't have to draw the graph, but sometimes it'll help. So this is cylinder. This is a cylinder. And this is z equals 0. And the cone is 4 minus that guy. So it'll be start from here and go down like this. It'll go down like this. Okay? So this is my region. This is my region. Ooh, maybe a different color. This is my region. So again, we need to solve. Do we have anything we need to solve? We need to solve it. So when z equals 0, and z equals 4 minus this guy, so when they are equal to 0 equals 4 minus x squared plus y squared. So we exactly have x squared plus y squared equals 4. Equals 16. So the intersection there is 16. So maybe I'll draw slightly clearer. So it will look like this. If we draw the cone first, it will look like this. So this is the radius of 4. This is my cone. So this is z equals 4 minus x squared plus y squared. So this is, say, 0, 4, 0. But my cylinder is only x squared plus y squared equals 4. So this is my cylinder. This is here. This is here. This is here. So these are my region. These are my region. Okay? It's not the full thing. So this is my region. So again, when you see this, what integral method we want to use? So this looks like inside the cylinder, right? So what about we just use cylindrical coordinates? Since this guy is circular to me, it's really circular to me. So what about we use cylindrical coordinate? So in this case, I always like to integrate z first. So z will go from where to where? We go from z to this part, right? We'll go from z to this part. So z go from 0 to z go to 4 minus x squared plus y squared. But now x is r cosine theta and y is r sine theta, where r is from 0 to 2, theta is from 0 to 2 pi. So x squared plus y squared will be r squared. So it'll be this guy minus r squared, so it's just 4 minus r. So dz, and now dr, 0 to 2, d theta 2 pi, so dr, d theta. So please pause your video for 2 seconds. Am I done? Am I done? Is this the correct setup? Is this the correct setup? I'll give you 3 seconds. 1, 2, 3. The answer is no, since we missed an r here. Be careful. Whenever you do this kind of thing, you need to be careful. Do we need the times an extra thing? For cylindrical coordinate, we need the times an r. Polar coordinate, we have to times an r. For spherical, we need to times phi. We have to times low square sine phi. Okay. So speaking of the spherical coordinate, let's do the spherical coordinate. So if there's a heat source at the thing, so the temperature is this guy, and S is the radius 2. So I want to find the average temperature. So average temperature will just be like, okay, the triple integral and over the volume of that thing. So T average will be this guy, 1 over volume of S. S is the sphere of radius 2. And we have to do the triple integral over S, and this guy, x squared plus y squared plus z squared dv. That's it. But in this case, everything is x squared plus y squared plus z squared, and everything is spherical. But what about we just use spherical coordinate? Again, stop the video, write that with me. So what is x, y, and z? Please pause the video, pause everything, and try to write out the spherical coordinate for me. Okay? Okay, all right now. So it's below sine phi, cosine theta, no sine phi, sine theta, no cosine phi. Again, if that's a whole sphere, so the low will from radius 2 or from 0 to 2, go from 0 to 2. And again, theta is the whole circle, so theta will be 0 to 2 pi. But be careful, phi. For phi, it looks like this. We go from up to down, so this is phi equals 0, and go out down to phi equals pi. Be careful, we start from here, we start from the positive z-axis, and go down, and go down. So the whole circle will be equals pi. So there'll be phi from 0 to pi. So we just set up this. So volume of a circle, you can do the exact same thing, but I'll keep that from you. I'll do that myself. So volume of S is just 4 over 3 pi r to the power 3. So in this case, 4 over 3 pi 2 to the power 3. I'll leave it that way. So the triple integral will just be S, this guy, x squared plus y squared plus z squared. Again, x squared plus y squared plus z squared will be low square. If you remember this, will be low square. Will be low square. So you're taking the square root, so this will be low square. And be careful, we have to times the low square sine phi. And I usually do d phi, d low d phi d theta. So d low d phi d theta. So 0 to 2, 0 to pi, 0 to 2 pi. And we can simplify this. This will just be 0 to pi, 0 pi, 0 2. This is just low, and this is just low squares, low to the power 3, sine phi, and d phi, d low, d theta. We're done. This calculation is also easy, but yeah, I'll just stop it here. I trust you. Okay. So quick review on spherical coordinates. So if we have, this is more, even though I finished the handout, but I want to do something more. For example, if we have half circle, half sphere, theta is also from 0 to 2 pi, but be careful, phi will be from 0 to pi over 2. So this is what I say exactly like this one. So if I only have a half sphere, so phi will go from here, phi to 0, and going down to here. Only down to here, this angle is phi equals pi over 2. Okay, so phi is a little bit trickier. Phi is a bit trickier. And I think we've done something interesting before. For example, what about I have a cone? So when you see z equals x squared plus y squared, z equals x squared plus y squared. So if we use spherical coordinate, this will be phi cosine, low cosine phi equals this guy, low sine phi cosine theta. They are all square, but low square cosine phi sine square phi cosine theta square. So we can take out low sine phi, and this will be sine square theta plus cosine square theta equals 1. This is 1, so this is just low sine phi. So in this case, low cosine phi equals low sine phi. So become phi doesn't matter here. So it's just sine phi over cosine phi equals 1. So we can write phi equals pi over 4. Okay? So this is also easy to see on graph. For example, if you have a sphere like this, the cone look like this, the cone look like this, you can see that this is my phi. It's phi from 0 go to phi equals pi over 4. And the rotation remains. Okay? Of course, you can solve it by this, but you can also see the graph like this. So yeah, basically you can make the thing, for example, z equals k x squared plus y squared. We do the exact same calculation. It'll be low cosine phi equals k low sine phi, k low sine phi. So this is what we all done before. So low disappear. So we will have tangent phi is 1 over k. So the graph of this guy will be arctangent 1 over k. Okay? This is some tricky thing, but it's okay. It's okay. But what about what we do like reverse? For example, like this. Ooh, this is not circular at all. What about like this? This is z equals negative x squared plus y squared. So we do the exact same thing. So this will be phi equals arctangent negative 1. So what make arctangent equals negative 1? So it'll be negative 3 pi. Sorry, it'll just be 3 pi over 4. Something like this. Something like this. Since the whole circle, so you can see that again, this is phi from 0. This go on and this go on. And we already know that this is pi over 4. So the remaining one is 3 pi over 4. Or you can use the inverse trick and whatever. Okay? So some tricky thing, not tricky, something, since usually the whole sphere is too easy probably, but we need to check what if we have different kind of sphere. That's it. So I think I finished all the review, and this is all the review sheet. So again, for the actual final, this is my final information again, will be curved by 100, 430 to 630. Again, I'll send out the final information and C map and the C information probably on Tuesday, since the day before final, then everyone will know that. And the grading scheme, I already sent out an announcement and review section on Tuesday, and I'll see you there, and good luck with the final. And if you are still here with the video, please, if you have any question, any problem, contact me. Thank you. Thank you.